I welcome you to the live session, the second live session of the course on robotics. Now, here I have received a few queries from you people, and I will try to give reply to each of these queries one after another. And then if you receive any online query, that also I will try to answer. Now, the first query which I got, it is as follows. Thank you for giving a lot of information about the robotics. I have a small doubt, sir. The robotics exam will be conducted in the written type or multiple choice question type, sir. Please clarify the about doubt, sir. Once again, thank you very much. Now, I really appreciate your initiative for sending me all such queries and for giving me this opportunity to share my ideas also. The first one I am just going to give reply, which I have already read. Now, I am happy that you are liking this course and you have asked me regarding the exam pattern. Now, this exam will be online exam and the question paper will be some sort of MCQ question paper. So, I think I am clear. The next is what is future of self-driving car in India. Now, this self-driving car is actually one of the very important fields of robotic research nowadays throughout the world. Now, in India also there are a few initiatives, but the main problem which we are facing is actually in India most of the time we people do not follow the traffic rule. Now, if you want to make this particular mission of the self driving car so successful, so what you will have to do is all of us will have to follow the traffic rule very meticulously, and the condition of the road has to be improved a lot. Now, if you can maintain all such things, so there is a possibility in future you will find that there are a few autonomous car or the self driving cars in India. The next query is any job opportunity after completion of the course. Now, after the completion of this course, so I cannot give you any guarantee that I will be able to provide you some job related to robotics. But one thing I can tell you, whenever some companies are coming to your institute for taking some sort of campus interview, if you say that you have taken a course on robotics, so definitely you will be getting some weightage, and they may also ask you some very fundamental questions of robotics, and all such fundamental issues have been dealt in details in this particular course. So, there is a possibility you will be getting some indirect advantage by taking this particular the course on robotics. The next is how we measure robots' accuracy and repeatability. Is there a universal common methodology to be adopted for the same? Now, this I have already defined. I have defined the terms like accuracy and repeatability, and I have also tried to find out what is the difference between the accuracy of a robot and repeatability of a robot. Now, if you want to measure the accuracy and repeatability of the robots, so what you will have to do is you will have to find out the Euclidean distance between the 2 points. The first point is nothing but the point which is reached by the end effector of the robot, and the second point is nothing but the point which is either taught or which is calculated through some mathematical expression. And we try to find out the Euclidean distance between these 2 points. Now, if I know the coordinates of these 2 points, so very easily can find out the Euclidean distance. Now, this particular Euclidean distance will be the numerical value for this accuracy or the repeatability of the robot. The next query is what different challenges one has to face while designing a robot for space environment. For instance, HIL, that is hardware in loop technology. Now, this is very important, this question is very important. Now, important in the sense like what we do is we design some robots and we try to test its performance through some computer simulations, and once we are happy with the computer simulations performance, next what we do is we try to go for its hardware implementation. For example, say we try to implement that particular robot, its hardware in terms of controller, in terms of its motion planner and so on. And while testing the real time problem, so what we do is we see what is happening in that particular simulation package, and we try to take the feedback from the simulation package and try to implement on the hardwares. That means, if you want to control this particular robot, that is the hardware control of this particular robot, and at the same time I am taking feedback from this particular the computer simulation package. So, this particular combination is actually the philosophy behind this HIL technology, that is hardware in loop technology. Now, here if you want to implement this hardware in technology, hardware in loop technology, what you will have to do is, so you will have to make a very good provision for the software or the simulation. You will have to capture the feedback through this particular simulation package, and that particular simulation that the feedback we will have to implement on the hardware with the help of some the related hardwares. So, what you will have to do is, so you will have to completely test this combined thing, one is the software, another is the hardware, and that is the philosophy of this particular the technology. And definitely there are a lot of challenges if you want to make successful testing of the robot through both hardware as well as the software. So, I am getting one online query. So, let me try to read it out. So, in telesurgery, why two robots are manipulator? The master robot can be computer which is controlling a slave which is performing the surgery. Now, in telesurgery actually what we do is we try to follow the principle of the lead through teaching sort of thing. So, there will be a master computer and there will be a slave. Now, this master computer is actually the robot which is I should say that is nothing but the robot simulator. Now, this robot simulator is actually a physical robot which is kinematically equivalent to the main robot which I am going to teach, but this robot simulator does not have any such the motors, controllers, brakes and so on. So, very easily we can move, we can control, and while moving, while controlling, so we try to just try to collect the information in terms of the joint angles at a regular interval of time with the help of some optical encoder which are mounted at the different joints. Now, the same information we are going to use for the master robot, the slave robot rather, okay, the second robot, the robot which I am going to teach. Okay. So, there are two robots, one is the main robot which I am going to teach, and there is another robot which is actually a robot simulator. Now, if I call that robot simulator is nothing but the master, then the main robot which I am going to teach is nothing but the slave, and that is actually the principle of the telesurgery. So, I think it is clear, the principle of telesurgery is clear, and I hope I have already discussed this principle of telesurgery while discussing the lead through teaching in much more details. Now, another the online query which I am getting, sir, now how is the hope for robotics in space research? Now, there are many fields in robotics, particularly in space, like where we can concentrate. There are many such research issues, particularly the hardware implementation, as I discussed a few minutes ago, like your hardware implementation will give lot of problems in space, but we will have to test all such hardwares, its applicability, the way it should work, and it should be based on your the performance which you are getting through the robot simulation. The same performance we are also going to get it on this particular hardware, that should be our aim. So, accordingly I will have to make all such arrangement ready for the hardware implementation, particularly in terms of motion planner, in terms of controller. So, I think it is clear to you, but there are many such challenges particularly in the space robotics. Why capacitive sensor is not a range sensor? Now, this capacitive sensor is actually that is called the proximity sensor, and by the term proximity we means that is the closeness. So, if this particular object is very near to the sensor, so there is a possibility the sensor will perform in a better way. Now, this capacitive sensor, as I told, that this is nothing but a proximity sensor, and it is different from the range sensor, because in range sensor what we do is we generally try to maintain a larger distance between the object and the sensor, whose distance I am going to measure. Now, in range sensor we generally use the principle of triangulation, and what we do is we take the help of either the light source or the sound source, and we create light or the sound with the help of some emitter, and that will be reflected by the object, and using the principle of triangulation, which I have already discussed in details, we try to find out what should be the distance between the object and that particular the sensor. So, actually capacitive sensor is a proximity sensor, but it is not a range sensor. The reason is, for range sensor we generally go for the larger distance between the object and that particular sensor, whereas the main principle of proximity sensor, that your object should be very close to that particular the sensor. The next point, sir, I am from CSE stream, I am learning robotics so that I can use it in my project. So, what will be the practical making and programming of robotics? When will the practical making and programming of the robotics will start? Now, this robots programming, particularly for the Puma series robot, the valve programming I have already discussed in details, and we have also done some experiment, and I have shared that particular video of that real experiments. Now, for different robots, so we will have to use different programming languages, but the main philosophy behind developing that particular the programming language, so that I have already discussed. Now, if you want to make some practical robots, so what you will have to do is you will have to gather information of the different modules of robotics. For example, you will have to go for its mechanical design, its kinematic analysis, its dynamic analysis, then how to find out the capacity or the specifications of the robots, the motors which I am going to use at the different joints, then how to control it and how to get the movement at the different joints according to our need, and how to make it intelligent. So, all such things you will have to study. Now, as you are a student of computer science, so very easily you can concentrate on how to make it intelligent, particularly you can concentrate on the robot vision or the computer vision. You can also concentrate on the robot motion planning. So, these are actually very good areas for doing research if your background is computer science. The next query, in cylindrical coordinate system, so we are considering the 4×4 rotation matrix, but for the composite matrix roll, pitch and yaw, so we are considering 3×3 matrix Y. Now, the moment we consider the composite rotation matrix, actually our main purpose is how to find out the orientation. Now, if you are interested only in the orientation, for example, the orientation of the end effector of a robot with respect to the base coordinate frame. So, what you can do is, so you can go for the 3 cross 3 this particular matrix, but supposing that your aim is to find out what should be the transformation matrix. That means, the transformation matrix. So, let me write it here, say the transformation matrix of say end effector with respect to your the base, if you want to find out. So, what we are going to do is, we take the help of a 4 cross 4 matrix, and this is nothing but say R 1 1, R 1 2, R 1 3, then comes R 2 1, 2 2, 2 3, then comes R 3 1, R 3 2, R 3 3, then comes 0 0 0 1, and here we have got q x, q y, q z. So, this is nothing but a 4 cross 4 transformation matrix. Now, here inside the transformation matrix we have got the rotation terms, that is the rotation matrix, and this is nothing but the 3 cross 3. So, this is actually nothing but the 3 cross 3 rotation matrix, and this is the position vector. Okay. So, if you are interested only in the orientation, so you can concentrate only on the 3 cross 3 matrix, but if you are interested to know both about rotation as well as the position information, that means, if you want to find out the complete transformation matrix, that has to be 4 cross 4 transformation matrix. So, I hope you have understood that within that particular transformation matrix, so this particular your 3 cross 3 rotation matrix is nothing but a sub matrix sort of thing. Okay. So, I think it is clear to all of you. The next query is, how can I know, how can I start to get the very basic robotic practical knowledge in my college, and what further should I do for higher studies if I am inclined with robotics to that extent. Now, what you will have to do is, like I hope you are doing your BTech somewhere in India, I hope. Now, what you will have to do is, you find out what type of robots you have in your lab, okay, and you try to carry out some sort of preliminary experiment. For example, if you have got some sort of serial manipulator, like say 6 degrees of freedom serial manipulator or 3 degrees of freedom serial manipulator, the first thing you do is, you try to control that particular manipulator according to your need, and see whether you are able to control according to the requirement or not. So, if you start doing experiment with the available robots in your college, so you will gain some confidence, and then in future if you are interested in masters or PhD, so you will have to apply in appropriate places, okay, for your higher studies in robotics. Now, here in India, almost all the IITs are having more or less good robotics lab. Here at IIT Kharagpur also we have started one center for robotics, and even in IISc Bangalore also they might have some facilities if you want to carry out some further study or higher study in robotics. Now, the next query is, why do not you conduct a workshop on it in Hyderabad? Now, I am ready to do, the only thing which you will have to do is, you will have to organize, you will have to take the responsibility of organizing this workshop, and I will be very happy to help you. I will be visiting that place, I may be there for a few days just to organize this particular workshop. Now, this type of workshop I have already done it at RDSO, the Steel Research Center at Ranchi. So, what I did on 2 visits, so I had to be there for almost 10 days, and I was the only speaker, and I actually conducted one workshop for them a few months ago. So, you are very much welcome. So, if you are really interested, you can organize and inform me accordingly, and I will have to find out a suitable time according to my availability also. Now, the next online query which I have got, which is more accurate, absolute optical encoder or incremental optical encoder. Now, here whether it is absolute optical encoder or incremental optical encoder, its accuracy depends on how much is the resolution. That means, your how many tracks or concentric rings you are going to use. Now, if it is binary, so what you can do is the resolution is nothing but 1 is to 2 raised to the power n. That means, the whole periphery of 360 degree. So, we are going to divide into 16 equal parts. Now, if n is equals to 4. So, if there are 4 concentric rings, then over 360 degree rotation can be divided into 16, that is nothing but 2 raised to the power 4 equal parts, and that is nothing but the resolution. So, let me repeat, whether it is absolute optical encoder or incremental optical encoder, its accuracy depends on the resolution, but if we compare this optical encoder and the absolute optical encoder and incremental optical encoder, absolute optical encoder will be more costly, because you will have to use more number of photo detectors, and the number of photo detector is kept equal to the number of concentric rings. On the other hand, on incremental optical encoder, we need only 2 photo detectors. Okay. The next query, I would like to request to give more practical examples to get a better way of understanding. I would also like to know what is industry support. Now, as I told that we got some positive response from a few industries, like as I told that your Steel Authority of India, their R&D section, they took some initiative, and I conducted one workshop which I have already mentioned. Then your Reliance Industries Mumbai, they also showed some interest, and there are some other industries also they are showing some interest on the robotics. Now, regarding the more practical examples, now if I want to take more practical examples, so I need to have a very well equipped lab for the robotics. Now, we have already started, as I have already mentioned, that at IIT Kharagpur we have started a new center for robotics, and there we are going to purchase around 15 to 18 robots, different types of robots, and there will be very good facilities for conducting experiments also. So, in future there is a possibility that once our center is ready, there is a possibility that we can offer another course on robotics, and that particular course could be only on how to carry out experiments on the real robots. So, the 20 hours that particular the recording will be only on the lab facilities on the robots. So, which actually we are in process of development. So, I hope in future there will be a very practical course from our center, might be from me only, okay, and that will be on how to carry out experiments on the real robots. Sir, what is the physical significance of cylindrical and spherical coordinate system? Why we convert into these forms using Cartesian coordinate system? Now, this is very important. Now, if you see the position of a point in 3D space can be represented either in Cartesian coordinate system, like say if it is 3D. So, what you need is your x information, y information and z information. The same position of a 3D point in 3D space can also be represented with the help of the cylindrical coordinate system or the spherical coordinate system. So, in cylindrical coordinate system, so what we do is we take the help of two linear movement and one rotary movement. On the other hand, in spherical coordinate system, we actually take the help of some rotary movements. And in Cartesian, as I told, that we take the help of the three linear x, y and z. Now, the reason why I have discussed all such systems, just to tell you that the same position of a point 3D point in 3D space can be represented using any of the system, and if you want to control the movement of the tip of the manipulator, so you can choose any of these three coordinate system and you can control the tip of the manipulator accordingly. The next query, kinematics and dynamics, some detailed explanation, sir. Now, kinematics and dynamics I have already discussed in much more details. Now, let me tell you in short. Actually, this is not a course only on the kinematics and dynamics. Had it been a course only on kinematics and dynamics, so we could have discussed this particular kinematics and dynamics in much more details, but here in this particular course, so what I have done it, I have tried to touch all 4 modules of robotics like kinematics, dynamics, control scheme and intelligent issues, and that is why the kinematics and dynamics part I have actually cut it short little bit, but as I told, the main purpose of kinematics is to study the relative movement of the different links without considering the reason behind that particular the relative movement. And the purpose of dynamics, as I have already mentioned, that we try to determine how much is the force required if it is a linear joint, how much is the torque required if it is a rotary joint, and we try to find out how we try to calculate what should be the torque requirement or the force requirement, like if you want to generate that particular movement at that particular the joint. So, that is the purpose of dynamics, but as I told, there are some other methods also. For example, say for this kinematics, there is another very efficient analysis with the help of screw algebra. So, which I have not yet discussed in this particular course, because so much time was not there. Similarly, on dynamics, there are some other approaches. Now, in this course, I have considered the Lagrange-Euler method. Now, there are Newton-Euler's method, and I can also use D'Alembert's principle just to carry out this dynamic analysis. Now, those have been kept for the future. If we make a separate course on kinematics and dynamics, so those things we will be discussing in much more details. Now, one online query I have got, what is the difference between the range sensor and proximity sensor? Now, the difference between the range sensor and proximity sensor is lying within the meaning of the terms proximity and range. Now, by proximity we means the closeness. Okay. Now, if the object is very close with respect to the sensor, so we will be getting better response and we will be able to find out the distance between the sensor and the object. For example, say if I consider the capacitive sensor, now we have got one, say the metallic disc, and that is nothing but you can say that is the sensor, and we have got an object. The moment the object comes very near to this particular the very thin metallic disc, what will happen is there will be some amount of charge accumulation due to say static electricity. Now, due to this accumulation of charge, the capacitance of this particular sensing electrode is going to increase. The moment it crosses the some sort of threshold value, that oscillation starts, and if we can measure that particular oscillation and that measured oscillations will be converted to some output voltage with the help of some electrical or electronic circuit. Then by measuring that particular voltage, we can find out what should be the distance between that object and the sensor. Now, this will be applicable if the object actually comes very near or at a proximity to this particular the sensor. On the other hand, for the range sensor, so the principle which you use, like there could be the object could be too far from this particular the sensor. So, might be too far in the sense might be a few meters. Okay. So, if the distance between the object and this particular sensor is a few meters or might be in kilometer range, there is a possibility the range sensor is going to work, but for the same distance your proximity sensor is not going to work. So, this is the difference between the range sensor and proximity sensor. The next query is your sir, one of the TA Mr. Amit Das had replied to my query about providing opportunity for internship after completing the course. He replied that you all will provide internship from IITs to those who perform excellent during the course. So, I just want to know the details about the internship, something like its period, our role in the internship, its criteria of selection and all other basic things which happens during internship. Now, we have already mentioned that if you take this particular course on robotics very seriously and if you can perform well, if you can get say EX grade sort of thing, and if you show some interest to do some sort of internship particularly at IIT Kharagpur, and as I told we have started a new center. So, we will try our level best to give you some opportunity to do some sort of summer internship or say winter internship, and where so you will be able to concentrate on a work related to your interest and our interest. Now, if you can tell one problem on which you want to work and if it is found to be suitable, so you will be allowed to work on that particular problem, or we are going to give you some research problem or a small part of the problem where you can do some sort of innovation also. But remember one thing, for this type of internship we are not going to give you any scholarship. Now, recently one mail has come from NPTEL office that they are going to give 2 scholarships for the internship per faculty member, and for that you will have to apply, and based on your performance in your college exam, the performance in this particular course, and based on your CV and interest, only 2 students will be selected to work with each faculty. For example, the robotics course is taught by only me. So, I will be taking only 2 such students for which some amount of scholarship will be paid by the NPTEL office. So, I think I am clear. The next online the query which I have got, please explain the uses in robotics of force closure and form closure. Now, actually this thing I have already discussed, the difference between the force closure and the form closure, but your query is how to use this particular concept in robotics. Now, this particular concept of force closure and form closure, that will be used while designing the end effector or the gripper which is generally attached at the wrist joint. Now, the purpose of using this end effector or the gripper is to grip the different types of joints, different types of objects. Now, supposing that the object is very heavy and we may need some sort of extra force to grip it, otherwise there could be a slippage. So, what I do is with the help of the robotic fingers or the grippers, we put some force on the object just to grip it tightly. And if I just go for the form closure, the geometry, because that particular the object's geometry, the cross section is going to help us for gripping of that particular object. So, there is a possibility if you go for form closure, so we may not need so much force to grip that particular the object. So, just to summarize, for force closure, it may be required that the robotic fingers will have to put more amount of force. On the other hand, in case of form closure, so it may not require so much force to be put or so much load to be put just to grip that particular the object. So, this is actually the applications, like if you want to design and develop suitable gripper. So, you will have to see whether you are going for the form closure or the force closure. The next query is your sir, the areas we are learning here, kinematics, dynamics, etc., how can I apply this knowledge in making a real robot? Now, if you want to make a real robot, then the knowledge of kinematics, dynamics, mechanical design, then comes control scheme and how to make it intelligence, all are important. So, this kinematics dynamics if you study and supposing that you have designed one robot, your mechanical design is ready. Now, whether that particular mechanical design will be safe to perform some particular task, okay, that has to be tested, and that is why kinematics and dynamics is particularly required, because if you want to arrive at the specifications of the motors which you are going to use at different robotic joint. So, you need to carry out the dynamic analysis, otherwise you will have to do some sort of error and trial method just to find out what should be the specifications of the motor. So, all 4 modules in robotics are actually very important if you want to design and develop robots. Achha, if not, please tell a way to learn to apply those, particularly how to program those. Now, the purpose of robot programming is to teach, okay, like you are going to teach a robot that you perform this particular task. You start from this particular point, reach that particular point, second point through a number of intermediate points, that type of thing. So, the task which is to be performed by the robot, that you will have to teach with the help of your this programming language. But here I just want to make one thing clear. The purpose of robot programming is not to make it intelligent. So, the purpose of robot programming is just to control the robot, but if you want to make it intelligent, so you will have to take the help of your motion planning, the motion planning algorithms you will have to use, you will have to find out what should be the shape motion, and then how to implement, you will have to take the help of some sort of adaptive controller. So, all such things actually are related. The next is hybrid PKM. Actually, this particular information is incomplete, but this parallel kinematic machine, what we mean is basically these are all parallel manipulator. Now, I have discussed little bit, but not in much more detail that parallel mechanism or the parallel manipulator. Now, the purpose of using parallel manipulator is if we want some more load carrying capacity. So, what I do is, so I have got a top plate for this particular the parallel manipulator, and that is nothing but the end effector, and this particular top plate or the end effector will be supported by a few legs, and these particular legs will be placed in parallel, and at each of these particular the parallel legs there will be a few joints and a few links placed in series. So, this will be actually the structure more or less for this parallel manipulator, and I think while discussing the degrees of freedom of a robotic system, I took some example of the parallel manipulator. So, I will request you to go back to that particular the lecture on degrees of freedom. So, you will be getting more clear idea about this parallel manipulator. Sir, if I want to get more knowledge about robotics, which book should I prefer? Now, here I just want to tell you that not even a single book is complete in terms of 4 modules of robotics. Now, if you want to get all 4 modules of robotics, now the textbook or the reference books which I have mentioned in this particular course should be sufficient. So, as I so far as I can remember, I mentioned about 1 textbook and 2 reference books. If you read these 3 books, I think you will be getting lot of information, but as I told that you will not find even a single book, whether it is in India or in abroad, which will carry all the information of robotics, all 4 modules of robotics you may not get in one book. Next is what should I do? What should I do to know chipset in robots? Now, this is very important, like if I just go for the hardware implementation. So, you will have to implement all such things in the form of your chips, like some sort of hardware chip sort of thing. Now, for example, say the sensors could be in the form of chips, then comes the controllers could be in the form of chips, motion planner could be in the form of chips, and on a particular hardware. So, all such chips will be there and there will be lot of interactions, and particularly the feedback system, the closed loop control system should also be implemented with the help of these particular the hardware. Now, if you want to design and develop the real robots, so nowadays in fact, we should go for some sort of your the chips and how to combine those particular chips just to design and develop one complete robotic system. So, those things we will have to learn. The next is how important for a roboticist to learn programming and how artificial intelligence is going to influence in robotics. Now, this I have already mentioned that if you want to teach a robot or if you want to give a control command to the robot, so we generally go for some sort of programming language. For example, VAL is used just to teach say Puma series robot, but if I want to make it intelligent, so this robot teaching is not going to help you, and there we will have to take the help of some sort of the algorithm, and those are known as the motion planning algorithm. So, a huge literature is available on robot motion planning, and in this course in fact, I have discussed some of the very popular traditional tools for robot motion planning, but there are a few tools for non-traditional tools for robot motion planning, which I have not yet discussed in this particular course, which will not be taught in this particular course, and those things will be taught in some other course in future. Now, the next is what is the future of robotics in India, particularly in our country. We have got a very good demand for the robots, not only in manufacturing units, different manufacturing units. So, nowadays the robot has got its applications in medical science, in your space science little bit, okay, and all such fields actually we can explore, like how to use robots. Now, if you see in India as on today, robots are being used in some of the good industries, okay, just to do some sort of machining operation, pick and place type of operation, and some sort of your spray painting type of operations, but there are a huge scope for robotics in India. Now, here I have got one online query, why robotics and automation is two different, what is this? Terms. Okay. Any significant difference between the two? Now, if you remember the very definition of the term robot while defining. So, I have defined a robot in different ways if I remember correctly. Now, the main theme of these particular robots, the robots are automatic machine, and these automatic machine will be able to perform a variety of tasks. So, in that sense actually robotics and automation they are having similar type of meaning, and moreover if you want to automate any factory, any manufacturing unit, so we will have to take the help of the robotic technology. The robots are to be used if you want to automate any manufacturing unit. So, these two terms are actually related. So, by robots we means is a automatic machine, and by automation of a factory if you want to implement, we need to take the help of the robots. So, they are related, I should say. The next is your question on DH parameter setting rule, but unfortunately here there is no the questions mentioned here, but let me tell you now this DH parameter setting like Denabet-Artenbach parameter setting, this I have discussed in much more details. I have solved some numerical examples also. Now, in short let me tell you the purpose of your this DH parameter setting is how to assign the coordinate system at the different joints. Now, to assign the coordinate system at the different joints, so you will have to follow certain rules, and those are nothing but the DH parameter setting rules. And if you want to define those rules, we will have to take the help of a few terms. If you remember, I defined 4 terms like length of a link, angle of twist, then link offset, the joint angle. And with the help of these 4 terms, actually what you can do is you can frame the rules, and which are nothing but your DH parameter setting rules. And in those DH parameter setting rules, what you will have to do is first you will have to select the z axis. If it is a rotary joint, the axis about which I am taking the rotation is the z. If it is a linear joint, the axis along which I am taking the translation or the linear movement is nothing but the z. The next is you will have to select x. If the two z's are found to be parallel, then there will be a mutual perpendicular distance, and that particular mutual perpendicular distance is nothing but the length of the link. If the two z's are intersecting, they are lying on the same plane and they are intersecting, the length of the link will become equal to 0. And another possibility, the two z axis, say z I and z I minus 1, they are lying on the same line, they are collinear. Now, in that case your x axis will lie on a plane which is perpendicular to both the axes z I and z I minus 1. And once you have got this particular x axis, now y is nothing but z cross x. So, z is a vector, x is a vector. So, its vector product, that is z cross x, is nothing but the y axis. So, those things I have discussed in much more details, and using this DH parameter setting rule, if I can assign the coordinate system at the different joints, then I will be in a position to represent the position and orientation of the end effector with respect to the base coordinate frame and vice versa. So, I can carry out or I can find out the information of the position and orientation of end effector with respect to the base coordinate system and vice versa, if I can set this particular your DH parameters properly. The next query actually the online query, can value of accuracy be negative? Now, as I told, the way this particular your accuracy has been defined, accuracy is nothing but the deviation of the actually reached point with respect to your the calculated point. Supposing that the calculated point has got some coordinate and your reached point has got another coordinate. Now, ideally speaking this would match, but there is a deviation. How to find out the accuracy? Accuracy is nothing but your the Euclidean distance. How to find out the Euclidean distance? It is very simple, square root of. So, you will have to find out dimension wise the difference and square of that. Like for example, if the coordinate is x 1 y 1 z 1, another point is x 2 y 2 z 2. So, your the Euclidean distance will be nothing but is your x 1 minus x 2 square plus y 1 minus y 2 square plus your z 1 minus z 2 square. So, this is nothing but the Euclidean distance. Okay. Now, you see inside this your square root we have got what? The sum of all the squares. Now, the sum of all the squares has to be positive or the minimum value could be 0. Now, if it is an ideal, then definitely this will become equal to 0. Otherwise, this will be a positive quantity and your square root of a positive quantity has to be positive. Okay. The next question is your, as telesurgery technology comes from India or not. Now, this question is not very clear, but I hope you are going to ask me whether telesurgery has been developed in India. So far as I know, it is not developed first in India. Anyway, so we have in India we have got a few telesurgery technology. No, I am sorry. So, I thought this is your teleoperation. Telesurgery technology is, so far as I know, in India we do not have till today a complete setup for telesurgery, but in Japan it is very popular. I am sorry, I thought I actually made the mistake. I thought this is some sort of tele control or that type of thing, but telesurgery, so far as I know, in India we do not have even a single setup ready, the complete setup ready in our country. So, next is, which one is the best software for analysis of robot kinematics and dynamics? I should say you can take the help of that Adams software. Adams software has got kinematics and dynamics module and that is reliable also. So, we can go for Adams. Okay. How much percentage success get by our country in robotics and how much we developed in robotics? Now, while discussing the brief history of robotics, I have already mentioned that we in India we started bit late. Although the first robot was developed, the first patent was filed in the year 1954, if you remember. Now, in India actually we started making robots around say 81 sort of thing, okay. And that is why we are a bit late to start, and that is why we could not make much progress also compared to the countries like Japan, USA. So, these countries have made, and there are some other countries also like Korea, South Korea has also done good progress in robotics, but we are lagging a little bit behind. But so, we will have to work very hard to reach that particular the level. What type of sensors and commands or programs used in Sophia robot to show facial expression? Now, this I have already mentioned that Sophia, so far as I can know, that this is the most sophisticated robot, and here in Sophia we use multiple sensors. We collect information with the help of multiple sensors, and there will be multi sensor data mining sort of thing, so that we can collect the actual information. And as I have mentioned, the Sophia is not only intelligent, it is emotional too. Now, here the facial expression, you see ultimately Sophia is a robot. So, it is a machine, it is an automatic machine. Now, for this any facial expression if you want to make, so what you will have to do is we will have to control the movement and there should be some controlled movement with the help of some motors at a few joints. So, any facial expression is a combination of the movement of the different joints, different motors, and whatever facial expression we get, it is a combination of that. Now, if it wants to generate a special facial expression, definitely a set of motors ought to be in working condition, ought to be operated to create a particular the facial expression. For example, say whenever we create some facial expression, how do we create? The moment we create some facial expression, we use our muscles, multiple muscles, and we have got some sort of hydraulic system also, like where working fluid is the blood. So, any facial expression if you want to generate, we take the help of the movement of the different muscle. The same thing has been copied there also. So, the next is your next is how will this course help us to get a job in the field of robotics. As I told that during your campus interview, if you say that you have taken a course on robotics, so I hope you will be getting extra advantage. The next is there any industrial collaboration for the course, so that we may get a job or interview call. So, I cannot give you any direct assurance for that, but as I told, if you say during your campus interview that you have taken a course on robotics, I hope you will be getting some preference and you will be getting some advantage out of that. So, what is the current scenario of jobs in robotics in India or better scope in other countries also? So, as I told, as on today in India, there are a few manufacturing unit, they are using robots. There are a few robot manufacturing companies also nowadays in India. So, there is a possibility you may get some employment in those robots manufacturing companies, particularly in Noida near Delhi, there are a few companies. In Pune, there are a few companies. Bangalore, there could be a few companies. Okay. Bombay, there could be a few companies. Okay. So, all such you will have to find out. Nowadays, all such informations are available through the website. And in abroad, of course, you have lot of opportunities. Now, how is robotics related to machine learning? This I have already mentioned, that if you want to make robot intelligent and autonomous, we will have to take the help of your machine learning algorithms. How to get a job if no company related to robotics is coming to campus for placement? Now, as I told that in India, we are lagging behind in terms of robotics. So, you may not get a particular company which will come only to take people related to robotics. Okay. But as I told, you will be getting some advantage in your campus interview, but as I told also told that there are a few robots manufacturing companies in India. So, if you are really interested, you can be in touch with them. Now, next is, will there be any practical session conducted, because only by knowing theory it is of no use, but we get an opportunity to those sessions, it would be helpful. As I told, so the main purpose of this particular course on robotics was to give you some detailed information of the 4 modules, and that was the main aim of this particular course taught by me. But in future there will be a few more practical oriented course on robotics. And as I told that we are making a very good center, very good lab at IIT Kharagpur. So, in future there is a possibility we will be able to float, or you will be able to develop another course which will deal only with the practical applications of robots, but you will have to, for that you will have to wait little bit. Is there any other query? So, I hope I am able to give at least some reply to your queries, and I hope you are enjoying this particular course, and you are learning a lot through this course, and I wish you all the best. Thank you.